Welcome back. This is Mr. Wakefield. We're looking at section 10.2 right now. You can see that 10.2 is on the same worksheet as 10.3. We'll get to 10.3 eventually in a separate video here. 10.2 first, and we're going to look at what we call ellipses. Ellipses have some similarities to circles, but they're definitely not the same. We'll see the differences here in just a moment. Let's start reading here. It says an ellipse is a set of all points on a graph, the sum of whose distances from two fixed points is constant. So what they mean by that is every ellipse, just like a circle, which I have up here, I drew this in the last video. Every ellipse, just like a circle, has a center. And so this is what an ellipse normally would look like. Sometimes it'll be a tall in this direction like this as well. Okay, and then it has a center point. Okay, so sometimes it'll be long in the horizontal direction. Sometimes it'll be long in this direction. But they both have a center, a circle and an ellipse. But the difference with an ellipse is that in addition to the center, you have what we call two focus points. Okay. You're not going to need to be able to find those focus points, but knowing about focus points in general will help you understand what an ellipse is. Now remember we said that with a circle, every single point on the circle is what? It is the same distance away from the center, and we call that distance the radius, or r for short. Okay, well with ellipses, let me just pick a point. I'll pick any point on the ellipse, all right? Say I pick this point right here. Let's just pretend that the distance here is, let's say, 2. You don't have to write this down, by the way. You can start writing when we actually get to the problems here. You can if you want to, though, obviously. But let's say that this distance right here is, say, 5, okay? So what they're saying is that if you add up those two distances, it's 7, right? Okay, so if you take any other point on the line, or I'm sorry, on the ellipse, any other point at all, let's say this one just as an example, then if you then take these two distances, in other words, the two distances from that point back to the two red focus points, they also will add up to 7. And that will happen on every single point on the ellipse. Okay, when you add up those two distances back to the two focus points, it will always add up to the same thing. So let's just say, for example, that this was 3. Okay, if that was 3 right there, then since they have to add up to 7, these two lines right here that go back to the focus points, then this must be 4, huh? Okay, so that's how ellipses work, all right? Instead of being the same distance away from one center point as it is with a circle, you now have the same sum of distances from two focus points. Every single point on the ellipse is that same sum of distances, meaning if you add it up from that point back to the two focus points and you add up those two distances will always be the same. Another thing I want you to realize is that the closer those two focus points are together, sometimes they're really close to the center, the two red points, and sometimes they're really far apart. The closer they are, the more it will look like a circle, and the further apart those red points are, the more stretched out the ellipse will be. Okay, now again, you don't have to find those red points. I'm just telling you this to kind of help you see the difference between a circle and an ellipse. But as you can see here, it creates kind of like an oval shape, and sometimes it will go in this direction as well. And when it does that, then that means that the focus points go in a vertical direction like this, and they're always the same distance away from the center. Again, you don't need to find them, but I'm just letting you know that. And so that's how ellipses work. Okay, so now let's actually learn how to actually graph one. You'll see that there again is some similarities between the equation right here. There it is. Where you got the two brackets, you got the x minus h squared, you've got the y minus k squared. But the two big differences is that instead of having r squared over here, you just have the number 1. And it is always the number 1. If it's not, you got to make it the number 1, and I'll show you how to do that. All right, but you can't graph. You can't even determine what the graph, what its characteristics are until that's equal to 1. But once it is equal to 1, then you take whatever's underneath these two brackets, and there can't be anything in front of the brackets either. All right, we'll talk about that. Sometimes that'll happen, and so you'll need to get rid of those numbers. You can't have anything in front of the brackets, but you can have numbers underneath the brackets with a fraction bar there. You see a couple fraction bars there. And of course, this has to be plus as well. All right, so when it looks like that, and again, x and y are the only variables here, all right? The other letters you see here in the formula are all constant numbers, all of them. H, K, just like it was in the last section, H and K are constants. A and B will be constants as well. Notice it says A squared and B squared, so it's going to kind of work the same way as the R squared did in the circle formula, all right? It'll kind of be a similar thing with that, but again, we'll get into that here. So you'll notice in the first problem, and I'll put this side by side here, you'll notice in the first problem here that it already looks, let me bring it down, there's problem A right there, and I'm going to put the formula that's at the top of the page right underneath it here. You can see that it already takes on that same look. So we don't need to change the equation at all. We don't need to move anything around or transform it in a different way like we will later and like we did sometimes with the circle problems. All right, it already looks like this, where you've got your variables x and y, you've got your constant numbers with it, -1 and 2. You've got your constants underneath it. Remember I said that these are constants underneath the fraction bars. And you've got your 1. And you've got your plus in between as well. So it all fits, and as long as it fits perfectly into this setup here, and again, remember, just like with circles, you can have pluses inside of the brackets. That's just going to affect the sign, that's all, but that still fits in this. But it fits perfectly into this, doesn't it? Okay, and so that means I can now, it's kind of similar to what we did with circles, where you find out the center first. What is the center right here? What's the center going to be? The center is going to be that you computed exactly the same way you did the circles. That means you take the numbers that are with the x and y inside the brackets there, and you change the signs of them when you figure out the center. So -1 is going to become 1. +2 is going to become -2. And the other thing we need to do, though, is there's no radius this time because we don't have just one distance, all right? There's no radius, all right? Radius is when you have a circle and it's the same distance all the way around, okay? Like we talked about here. We don't have that kind of thing here. We got a sum of distances. Not that the A and B are those sums. I'm not saying that. That's a different thing. But I'm just showing you that the radius does not apply to ellipses. Okay. What does apply is these numbers right here. Since the formula says that those numbers are A squared and B squared, then just like we did with R squared, we need to take the square root in order to figure out what A and B are equal to. Okay, so the square root is 4, and the square root here is 3, right? Okay, I'm going to write it over here. I'll tell you why in a minute. But it's 4 and 3. I'll actually put the arrow there. That's fine. I'll just move the arrow over. Okay, so it doesn't look weird. So we got 4 and 3, right? Okay. Again, they're not the radius. There's no radius here. But what it means is this. Because of the fact that the 4 is underneath the x and the 3 is underneath the y, what we're going to do is notice that when you have a xy graph, actually I'll look at it down here, excuse me. When you have an xy graph, you zoom out, there we go. When you're going along the x-axis here and you're looking at x's, you're going left to right, aren't you? So that 4 means this. It means to go left and right 4. Okay, again, I'll show you how that works here in just a moment. But it makes sense that since the 4 is with the x, and since the x-axis goes left to right, we're going to go left and right 4. You might be wondering, left and right from where? Okay, it's left and right from the center. All right, so actually, let me go and graph that now so you can see it better. So here's the center right here. I'm not going to change the scale on this one. It'll just be the standard marks here. Okay, and then left and right 4 means this. It means 1, 2, 3, 4 to the left. And let me make some marks here so I can count it out. And then I got 1, 2, 3, 4 to the right. Okay. And then that's what it is. And again, it's all because the 4 is with the x. So you go left and right. In other words, parallel to the x-axis. Okay. You go parallel to the x-axis if 4 is with the x. So since the 3 is with the y, you're going to do something similar. But the difference is that you're going to go parallel to the y-axis. And what does that mean? That means that you're going to go up and down. Up and down is parallel to the y-axis, isn't it? Because the y-axis goes up and down also. So we're going to go what? We're going to go up, 1, 2, 3 up. Make that mark right there. Put a dot there. And then we're going to go 1, 2, 3 down. And this gives me a 4 points here. Once you get those 4 points by going up and down and left and right, the rest of the graph is just simply doing the exact same thing that we did with circles. Okay, it's a nice round object. It looks almost like a circle, but it's a little bit longer going left and right because it's 4 instead of 3. That going up and down 3 is going to be a little bit shorter. So it's as if you're stretching the ellipse out a little bit in the horizontal direction side by side. Okay, but you draw it the same way. You start out with any point, same as a circle. You do not draw diamonds. Okay, if you draw a diamond, okay, that's not what an ellipse is. Just like I said with circles in the last video. What you do is you start out at any point, you go away from the center, and then you work your way towards the next point as you go towards it. Okay, and then you go away from the center, and then you eventually work your way to the next point. Okay, in a nice, smooth manner, no sharp turns or anything. So you go away from the center and then cut back in towards the next point. Away from the center, okay, and then cut back in towards the next point. And that, you guys, is how you graph an ellipse, okay? You can see, once again, that it looks like it was stretched out a little bit. If you grab the two ends here and stretch them this way, then it looks like you took a circle and stretched it out. All right, just a little bit in this direction. So it does look almost like a circle, but it is stretched out a little bit. That's what ellipses are all about. It's just that sometimes the stretching out will go in the vertical direction. All right, like I said earlier when I showed you this picture right here. Okay, sometimes it'll go in that direction. All right, we'll see that sometimes, but that's basically how you do an ellipse. Now, we talked about a lot of stuff there, so again, let's get some more practice here so we can start to get used to this more and more. All right, now, in this next problem here, you can see that the equation doesn't look anything like it's supposed to, but let me help you out with that. Okay, we want it to look like this, right? So, first of all, I want to make it clear here, you guys, that x squared over a squared plus y squared. In other words, you just have x and y instead of the brackets. Everything else is the same here, all right? X squared and y squared. Okay, this also is an ellipse. And the reason why that it is because this thing, look right here. This thing right here, x squared, that is the same thing as x minus 0 squared, all right? Same as, let me write it down, same as x minus 0 squared over a squared. You don't have to write this x minus 0 thing down. As long as you know that the minus 0 is there, hidden, invisible, all right, then that's fine. But this and this, these two things are the same thing, okay? And this one, though, looks like this over here, doesn't it? Which is what we eventually need our ellipse equation to look, all right? And we know this is an ellipse problem because the directions tell us that. So that should tell you, as soon as you see those directions there, that, hey, I need to make the equation look like this. I need to, okay? So since this is the same thing as that, and this fits into this over here, which is what we eventually need, the equation to look like, then that means that if you can make your equation look like this, then you'll know that it's the same thing as this here, and then you'll be good. Okay, so I say that because this current problem right here has just x squared and y squared in it. It doesn't have the brackets. Okay, but as long as you realize that this right here is x minus 0 bracket squared, and this right here is y minus 0 bracket squared, then that's what's important. Okay, but the problem though, we still have some issues here. Number one, we need to make this into a 1 right here. Okay, if we want to eventually make it look like this right here, we need to make that a 1, and we need to get rid of the 16 and the 9. Remember I said you can't have a 16 or a 9 or any number for that matter being multiplied by x minus 0 squared or y minus 0 squared, all right, which is what these two things are. Okay, you can't have anything in front of those brackets. All right, and we know that there's some invisible brackets here. Okay, this is what? This is 16 x minus, again, you don't have to write this. I'm just giving you a visual here. 16 x minus 0 squared, 9 y minus 0 squared. All right, you can visualize it that way. And now, so that helps us realize that, in order to get it to look like this, now that I've put the brackets in there, okay, now they get it to look like this, what do I got to do? The way you got to do it, if this is not 1 right here, what you normally do is you divide both sides of the equation by the same number, because we know that when you divide by the same number, it's going to be equal to 1. But if you divide one side by a number, you've got to divide the entire other side, not just part of it, but the whole thing by the 144 also, by the same number. Okay? Now, just like we did back in, and we've done this many times this semester, but especially in this section here, when you divide a polynomial by just a single term, you divide each part. Okay, but this is a little bit different because it's got brackets in it. Okay, but the way it works when you have a term times a bracket squared, and then you have a plus that's outside of a bracket, and then a term times a bracket squared again, it's basically the same idea as when you just have a couple of terms being divided by a term down here. Okay, you split it according to each term here. All right, so just like the pluses and minus separated these terms into 4 separate terms here, and that's why we had 4 fractions here when we split it apart, the plus here that's outside of the parenthesis is going to split this thing up into 2 parts as well. Okay, if there's a plus or minus inside of the parenthesis, that doesn't count, all right, when you split this apart. It's just the pluses that are outside, or the minuses if there's minuses outside. Those split it apart, okay, if it's in between the numerator there in the middle, okay, in between a couple of things here. Plus or minus would split it apart, all right. And so, but again, that's if it's not inside a parenthesis. So what happens is this. It goes like this. The plus splits it up like this, okay. And then the other side is 1. So we're almost there, all right? We got the 1 that we need. We need it to look like this right here. We got the 1, all right? And we got the numbers underneath also. That's great, all right? But the problem is we can't have the 16 and the 9 right there, okay? Because you can't have anything in front of the brackets, just like the formula over here tells me. You can have stuff underneath the brackets, but not in front of them. So what you do is you can cancel. You can't cancel inside the brackets, all right? When you have a term times a bracket squared and then just a term down here, you can't cancel the term down here with the bracket. You're not allowed to do that. It's similar to what we talked about when we talked about canceling stuff. But what you can do is you can cancel the 16 and that 144, all right? And you get what? You get 1 and 9. Here you get 9. You can cancel the 9 and 144. Just don't cancel the 144 with the inside the bracket right there. Okay. And you can't cross cancel. You can't cross over the plus sign, just like we talked about here. You can't cross cancel when you're adding fractions. You can when you're multiplying, but that's not what we're doing here. We're adding these. So the 9 and the 144, since they're in the same fraction, they can cancel. And we get what? We get 1 and 16. We divide both of those by 9. Over here, I divided both of the numbers by 16. And that's why I got 1 and 9 here and 1 and 16 here. Now, why does that work? It's because if there's a 1 in front of the bracket now, that's the same thing as having nothing in front of the bracket, isn't it? When you have 1 times a bracket, that's the same thing as nothing times a bracket, okay, because we know that there's an invisible 1 in front of the bracket when there's nothing there. So let me just clean up my mess here, and this is what I get. Okay. So I get that. So we want, if you got numbers in front of your brackets here, you guys, you need to make them equal to 1, and that will get the job done. Okay. And now it looks just like the formula that it's supposed to be like. Okay, it looks just like this. And so, because it looks like that, now we look at the H and the K. Okay, they both say minus 0, so that means that the center is what? The center is 0, 0, isn't it? Okay, if you change the signs to positive 0, it's still going to be 0 anyway. Okay, either way. So, that's our center. But, what does the 9 and the 16 mean? What is that all about? Just like in the last problem, okay, since the 9 is with the x, that means we're going to go left and right. Okay, why do we go left and right when it's with the x? It's because left and right is parallel to the x-axis, that's why. Since the 16 is with the y, then that means we're going to go up and down because the y-axis is up and down. So it makes sense we would go up and down if the 16 is with the y. But you don't go up and down 16, you go up and down 4. You got to take, remember, the square roots. Just like we did in the last problem, the square roots, and that tells you how far to go left and right and how far to go up and down. Once I set up my equation correctly, then you figure out the center and your left, right, up, down numbers. Once you've done all that now, then you're ready to graph. So we're going to go left and right. There's my center right there. Always do that first because you got to have something to build off of here. Okay, just like with circles, you got to graph the center first so that you can then measure it out from there. Left and right 3 means I'm going to go over here, over to the right from the center 3 times, over to the left from the center 3 times. Okay, and then up and down 4 means what? That means we're going to go, just like it says, up and down from the center, a distance of 4 in both directions here, up and down. So that gives me this right here. So once I have those 4 points in place, the left, right, up, down points, we once again just do the same thing we did with circles. All right, you start out with any point. You don't go straight to the next point. That would give you a diamond. All right, you just go away from the center a little bit, and then you cut back towards the next point like that. And you keep on doing that all the way around. Okay, a little bit away from the center, and then cut back in. Okay. In other words, don't go straight to the next point, but just go away a little bit further away from the center than you would if you went straight ahead. A little bit away from the center, further away. In other words, if there was somebody that was walking from this point to this point, and you said, no, you can't do that, and then they said, well, what do I do then? You say, well, let's go a little bit further away from the center at first, and then we'll eventually work our way to the next point. That's exactly the approach you want to take. All right, a little bit away from the center and then cut back to the next point. A little bit away from the center and then cut back to the next point. And that gives you an ellipse. Okay. Again, it's a little bit stretched out. It looks almost like a circle, but it's a little bit stretched out in the vertical direction. Okay, it looks like you took a circle and you grabbed the top and bottom of the circle, and it looks like you stretched it out like this. Okay, in the up and down direction, and that's what ovals are all about. That's what ellipses are all about. Okay. This next one here is kind of similar to This step right here that I did before I divided by 144, it's similar to that in that you got a number over here. You got your two brackets, and you even got a number in front of one of them. Since this one doesn't have a number in front of it, that means there's an invisible 1 in front of that. Okay, but otherwise it's very similar to this, where you had the 16 and the 9 along with the two brackets, and then you got a number over here which is not 1, so we need to make it 1. So we're going to do exactly the same thing. We're going to divide by 36, just like I divided by 144, in order to make this equal to 1 right here. But that means I need to divide this side by 36 also. And so what is that going to do? Well, if you've got a bracket squared plus a term times a bracket squared, again, that plus that's in the middle splits it up into two separate fractions like I mentioned in the previous problem. Let me write that down. Okay, like this. Okay. And then once it does that, we need to get rid of that 9. Okay, again, you cannot cancel, just to make it clear, you cannot cancel the 36 with something inside of the bracket. Can't do that. All right, when you got a bracket squared with two terms in it, okay, kind of similar to what we talked about when we talked about canceling. Like I said before, if you've got a bracket with two terms in it in the numerator and just a single term down here, okay, it would be like trying to cancel a red factor with a green factor, like we talked about back then. So don't. The point is, for now though, is don't cancel inside of this bracket that has two terms in it with a single term down here. All right, but you can cancel the 9 and the 36 though. The single term that's in front of the bracket and the single term down here can be canceled, and we get what? Well, if I divide both of those by 9, I get 1 and 4, and I want to make that 1. So you want to get 9 and 36 in lowest terms. That should make the 9 into a 1, and so you're on your way now. Okay, what does that end up looking like down here? Let me write that down. That's going to be... And you didn't need to cancel anything on the first fraction there because, again, you can't cancel the 3 and the 36. You can't cancel inside of that two-term bracket right there with the single term down here. So the only thing you could have done was cancel the invisible 1 with the 36, but 1 and 36 don't cancel. That's why I didn't try to cancel anything on that fraction. So let me write it out. I'm just making it clear why I didn't cancel anything there. So there we go. Pardon me for the arrows getting in the way there. Okay, there's an exponent right there. Okay, so it now looks like it's supposed to look, doesn't it? Again, don't determine your center or your left, right, up, down numbers until it's in this form, because the numbers change as you go from the original problem to get it into this form. The numbers change, so you got to wait until it gets to this form before you determine what those numbers are for the center and the left, right, up, down numbers. Okay, what is the center? Again, the center is figured out by taking the H and the K and changing the signs. In other words, taking the signs or taking the numbers that are with the X and the Y and changing them. So this is going to be positive 3 for X and negative 2 for Y. Okay, and then what does the 36 and the 4 tell me? Well, since the 36 is with the X, that means I'm going to go left and right a distance of 6, since 6 is the square root of 36. And then since 4 is with the Y, that means I'm going to go up and down. And what's the square root of 4? It is 2, and so I'm going to go up and down 2. Okay, so what I do is I graph, where is it? Oh, 3, negative 2, here we go. 3, negative 2. Right there. And then it says left and right 6. Let me zoom out there. There we go. Left and right 6. So I'm going to need to make a little bit of space here. 1, 2, 3, 4, 5, and 6. There we go. So 1, 2, 3, 4, 5, 6 to the right. 1, 2, 3, 4, 5, 6 to the left. Okay, and then it says up and down 2. This is going to be a really narrow ellipse this time. Okay, so I go up 2, 1, 2, and then I go down 2. That takes me to there. Okay, so because it's a really narrow-looking ellipse, as opposed to the previous 2 ellipses, which looked almost like circles, we need to be careful about how do we graph this to make it so that it doesn't look like it's a sharp turn right here. Okay, so again, we go away from the center towards the next point. See how I'm carefully turning here so that it doesn't look like, don't make it look like that, you guys. Okay, you don't want that. All right, that is not an ellipse. It's got to be curved all the way around, no sharp turns. Smooth and curved. So then I keep on doing the same thing. I go away from the center and go towards the next point. See how it's nice and smooth right there, no sharp stuff. Okay, on the turn there. We go away from the center towards the next point. Okay, nice smooth turn there. And then back towards the last point. All right. And that's your ellipse. Okay. So, let's take a look at the back side right now. All right. You can see the first 2 problems. What is that? Again, it's not required that you write this down, but just to let you know what I'm thinking here. I'm thinking that when we have x squared and y squared in an ellipse problem, which the directions tell us this is an ellipse, that automatically tells me that, oh, these are actually x minus 0 bracket squared and y minus 0 bracket squared. So you can see that this is already in the correct form. Over here, same thing. As far as the x squared and y squared, they look like this right here. And so just like in the previous 2 problems, I can divide both sides by 36 in the same way that I did in the front of the worksheet, and that will get me to the answer there as well, just doing the same method that we did there in the front side of the worksheet. And then this one, when there's nothing underneath that bracket, doesn't that mean that there's an invisible 1 right there? And the reason why I say that is because the entire rest of the equation already looks like it's supposed to look, doesn't it? You got the x plus 2 bracket squared, you got the number underneath, you got the bracket squared here, you just need a number underneath it, and then you got the 1 that you need. And so because the only thing that was missing was the thing underneath the bracket squared, and since we know that we can always put a 1 underneath anything, and it's still the same thing, it's not like I messed it up or anything, it's still the same thing when I put that 1 there, okay? Then if you put that 1 there, it is already in the correct form. You don't need to do anything else. You can immediately find the center and the left, right, up, down points right away now. Okay, in fact, the only problem out of these 3 right here where you need to do some work first before you do the center and the left, right, up, down points is on this problem right here where you'd have to divide out the 36 and get rid of the 9 and the 4 and all that stuff. Okay, so go ahead and try these 3 problems and then hit the play button when you're done. We'll take a look at the answers. Okay, on number 1 right here, again, it's already in the form that we need it to be in. Realizing whether you write it down or not, it's optional, but we realize that x squared is x minus 0 squared. Y squared is y minus 0 squared. And so it now looks exactly like an ellipse is supposed to look. So that means that the center is 0, 0, as you can tell from inside the brackets there. The number underneath x, since it's 64, that means we're going to go left and right the square root of 64, which is 8. All right, again, left and right because it's with the x. Y means up and down, so we're going to go up and down 10 because that's the square root of 100. Okay, now since these are pretty big numbers right here, you might be thinking, hey, I want to change the scale on my graph. That's okay. Just remember that similar to circles, you guys, you have to do the same scale if you're going to change it. You got to do the same scale on both the x-axis and the y-axis. Circles and ellipses actually are the only types of graphs where you're going to have to do that. We'll see some more different graphs here in the next section. You won't have to do that same rule here where both x and y have to be the same scale. But with circles and ellipses, it won't come out looking correct if you don't make both the x-axis and y-axis the same. What I mean by this is if you're going to do 2, 4, 6, 8 on the X scale, all right, you need to do the same thing, 2, 4, 6, 8 on the Y scale. All right, and so that's what I did here. And so let's go ahead and take a look at how this answer came out the way that it did. All right, left and right from the center. That's how I got these 2 points right here. If I go up and down 10 again from the center, it takes me to these 2 points right here. And then like we've been talking about, you draw a nice curved shape around that in the same way we talked about, going away from the center and then cutting back in towards the next point in a smooth curved manner, and you should be fine. And there's your ellipse right there. In number 2, okay, we start out with this right here, realizing that x squared and y squared are the same thing as those 2 brackets right there. We know we need to divide by 36, just like I did on the front side of the worksheet, in order to make this equal to 1. Okay, but when we do that, it will also allow us to get rid of the 9 and the 4. How does it help us do that? Similar to the second problem on the front when we had the 16 and the 9, when we split the fractions apart with the plus that's in between the 2 brackets here, being the place where you split it apart, just like on the front side of the worksheet, that plus is where you divide it into 2 fractions here. And then you cancel, not inside the bracket, but you cancel the 9 and the 4 with the 36 and the 36. Okay? Not cross-canceling. Keep the 9 with the 36 and keep the 4 with the 36. Don't cross over this plus. All right? So doing that, we get what? 9 and 36 reduced down to 1 and 4, which means that you have nothing in front of the bracket anymore. When there's a 1 there, you can write nothing. Okay? And then we got the 4 down here. The 4 and the 36 become 1 and 9. Dividing both of those numbers by 4, we get 1 and 9. And so that's why this now is going to be a 9 here with nothing in front there. Okay? The 1 means nothing in front, right? In this case. Because when you multiply by 1, it means it's the same thing as not writing anything there at all. Okay? And it's now in the correct form now, as you can see here. It's now in the correct form. And so, because it is, I can now realize that the center is 0, 0. I'll graph that in just a moment. And since the 4 is with the x, that means we're going to go left and right 2, because 2 is the square root of 4. Okay, y means up and down, so we're going to go up and down 3, because 3 is the square root of 9. And let's see how that all looks. So there's my center right there. Oh, sorry about that. Let me come down here. There's my center right there, right at 0, 0. We went left and right 2, like we just discussed. There it is up there. We went left and right 2, and we went up and down 3, and we drew our normal ellipse-looking shape. Okay, shape that looks like an ellipse. Finally, number 3, it's already in the correct form if you put that 1 underneath there, like we talked about before we started these problems. And so it's already in the correct form that it needs to be. That means that I can now reason that the center is what? Well, we change the sign of 2 and negative 3. That gives me negative 2 and positive 3. All right? And since 16 is with the x, that means we're going to go left and right 4, square root of 16. And since the 1 is with the y, we're going to go up and down. And what is the square root of 1, you guys? It's 1. And so we're going to go up and down 1. This is going to lead to a really skinny ellipse, skinny, narrow ellipse. All right, so I put my center there. Negative 2, 3 is right here. We went left and right 4, and we went up and down only 1. So it's really, like I said, narrow and skinny. So be really careful, like I said before, that when you graph it, that you make it a curved turn here on the edges, because it's so narrow, it's tougher to do that. Color this in extra dark here to make it clear to who's reading it, including me when I read your work, that this truly is a curved turn and not a sharp turn. Okay, so highlight that extra dark if needed in order to make it look like it's smooth and curved, all right, as opposed to a sharp turn. And there you go. So this is ellipses, you guys. Let me know if you have any questions about that. We'll continue with section 10.3 on the same worksheet in the next video. And you have a good day.